So in this section, we're going to take a look at some inequalities. And what we're going to do is we're going to solve these just the same way that we solved equations. But when we multiply or divide both sides of the equation by of the inequality by a negative number, we're going to reverse the direction of the inequality sign. Let's do some examples here. Here's number 1. Let's solve x minus 9 greater than 3. So as an equation, what we're going to do is we're going to add 9. Now we're adding, so we're not going to change the direction of the sign. We do that only when we multiply or divide by a negative. So what we're going to get here is if you just add 9, right now just add 9 to this side, add it to this side, we're going to get x greater than 12. Now in number 2, we're going to divide by 9. Let's do that. See what we're going to do. We're going to divide by 9. Now 9 is a positive number. And this does not cause us a problem, right? The only time we have to change the direction of the inequality sign is we multiply or divide both sides by a negative number. Now we're dividing into a negative number, but not by a negative number. So we're going to get, if you divide now this side by 9, 9 divided by 9 is 1, so we just get an x less than negative 18 over 9, so x is less than negative 2. Now here in number 3, we're going to make use of that property, that reversal property. What we're going to do here, of course, is we are going to isolate the x, we're going to divide by negative 16, alert. We're dividing by a negative number, so we're going to reverse the direction of this inequality sign. So we are going to get, now negative 16 divided by negative 16 is just 1, so x is now less than or equal to, okay, it's negative 96 over negative 16, and when I did that, I got 6, less than or equal to 6. Now if you just want to check this, what this says is that if we pick 6 or any number less than 6, put that number in here and multiply by negative 16, we'll get a number bigger than negative 96. Let's just try it. Just suppose we pick x equals 1. I'm just picking some number less than 6, so pick 1. So if you put that 1 into the original inequality, we are going to get negative 16 times 1 greater than or equal to negative 96. We'll get negative 16 greater than or equal to 96, negative 96, which is a true statement. Let's give number 4 a try. So what we're going to do is solve it just as if it were an equation. We're going to subtract 5. So let's say what it is we're going to do here. We're going to subtract 5, and that will give us 8m less than or equal to, now, negative 27 minus 5 is negative 32. Now we're going to divide by 8, alert, because we're dividing, but we're dividing by a positive number, so the direction of the inequality sign is not going to change. So if we divide by 8, we'll get m less than or equal to negative 4. What do you think about this one here? We got y's on both sides, so I think what I'm going to do here is, because I have more y's on the right side, I'm going to get all the y's on the right side. So I'm going to start here by subtracting 2y. So I'll say what it is I'm going to do. I'm going to subtract 2y. So doing so on the left side, 2y minus 2y is 0, so the y's are gone. We get negative 1 less than, now on the right side, 4y minus 2y is 2y minus 2. Now, let's eliminate this 2. What we're going to do is add 2. So I'm going to add 2 to each side. And doing so will give us negative 1 plus 2 is 1 less than 2y. Now, we're going to divide by 2, alert. We're dividing by a positive, so no change in the direction of that inequality sign. So we are going to get 1/2 less than y. Now look, this is okay. We're saying 1/2 is less than y, but that's just kind of awkward. I want the y on the right side. So, if you say something like this, like if I was to say, you are younger than I am, that's the same thing as saying, I am older than you are. So I'm just going to turn this around. What would happen if we did this problem like this? Instead of getting the y's on the right side and then having to change it down here at the bottom, what if we subtracted 4y and got all the y's on the left side? So to get the y's on the left side, what we would do we would subtract 4y. Right, we're going to eliminate them from the right side. So let's subtract. This one is positive, so we'll subtract. And doing so will give us 2y minus 4y is negative 2y minus 1 is now less than 4y minus 4y is 0, so we just get a negative 2 over here. Well, now what we're going to do is we're going to add 1. So if we add 1, we're going to get negative 2y is less than, now negative 2 plus 1 is negative 1. And now this negative 2 is multiplying by y, multiplying the y, so we're going to divide. That's right, what we're going to do. We're going to divide by negative 2. Alert, we're dividing by a negative. So this inequality symbol is going to change directions. And we will get negative 2 divided by negative 2 is 1. So we'll just get 1y, or just y. Change the direction, and we'll get negative 1 over negative 2. But negative over negative is positive, so we'll get y greater than 1/2, which is the same thing we got over here. Let's start number 6 by multiplying through by the 5 with the distributive property. So we are going to get 5x minus 5 minus 6x greater than or equal to negative 2. And now the 5x minus 6x, that gives us a negative x minus 5 greater than or equal to negative 2. Now, we need to get rid of this negative 5, so let's add 5 to isolate that x. So we're going to add 5 to each side, so this will give us negative x. Now, negative 5 plus 5 is 0, so that's gone. Greater than or equal to, and then negative 2 plus 5 is a 3. Now, what we've got here is negative x. We're not looking for negative x. We really want just x. So if we look kind of into this, what we really see here is we have a negative 1x greater than or equal to 3. And now we're going to divide by negative 1, but alert, we're dividing by a negative, so we're going to change the direction of that inequality sign. Let's do that. So we'll get negative 1 divided by negative 1 is just x, or just 1, so it's just x less than or equal to, now we're getting 3 divided by negative 1, so we'll get x is now less than or equal to negative 3. Now, in number 7, we're given this, that the velocity of an ultrasound wave through human tissue is represented as 1310 plus or minus 40 meters per second, where this plus or minus 40 meters per second, that gives the possible variation. So it could be something like this. What we're talking about here is this. The velocities could be 1310 minus 40 meters per second, or it could be 1310 plus 40 meters per second. Now, if we take a look at what's on the left here, 1310 minus 40 is 1270 meters per second. And over here on the right, 1310 plus 40 is 1350 meters per second. So now we're just going to say that the velocity is 1270 meters per second is going to be less than or equal to the velocity, which could be less than or equal to 1350 meters per second. And what we're really saying is that the velocity is where? I mean, just visually, where is it? The velocity is between this number and this number. In this problem here, number 8, we're going to rent a car that costs us $35 a day, basic price, plus 19 cents for every mile we drive it. And we're on a budget, say, of $73, so we're not going to spend more than $73, up to and including 73. And what we want to know is this: what mileage can we drive to allow us to stay within our budget? So we're looking for mileage. So why don't we introduce a variable? Why don't we say let m equal the mileage that we're able to drive? Now, how much is this car going to cost us to rent? Well, it's going to be per day. It's going to be the $35 plus 19 cents times every mile that we drive. Let's see if that makes sense. So it's going to cost us, how much is it going to cost us each day? $35. And then add on to that 19 cents times the number of miles that we drive. And all of that now has to be less than or equal to 73. So we can solve this. We're going to subtract 35. So that'll give us 0.19 m less than or equal to, now, 73 minus 35 is 38. See if we can get it to right here. 38. And then we're going to divide by 0.19. I'll do that up here. So if we divide, now alert, right, because we're making a division. So if we divide 0.19 m divided by 0.19, we'll get 1 m, or just m. Now, because we're dividing by a positive, this symbol does not change direction. So we're going to get less than or equal to 38 divided by 0.19. Now, 19 goes into 38 twice, but we have some decimals. So we're going to get m is less than or equal to 200. So we are asked what mileage will allow us to stay in our budget. So the answer is not m, does not involve an m. It's going to be just 200 miles per day. Now, here in problem 9, we're told that the design of an electric circuit specifies that the voltage cannot exceed 5 volts. So here's what we know right away. We know that the voltage cannot exceed 5 volts. Now, by cannot exceed, that means it could be less than or could be equal to. Does that make sense? Cannot exceed. Could be 5 volts, could be less than. And we're also going to use this formula here. Voltage is current times resistance. So we have the voltage here. So what we've got now is that the current, I'm just bringing it straight down, right? The voltage is the current times the resistance. And that has to be less than or equal to 5 volts. And we're given that the resistance is 2 ohms. So what we have is the current times 2 ohms is less than 5 volts. Now what we want is the current. So why don't we just divide by 2 ohms. So that's what we're going to do here. We're going to divide by 2 ohms. So we will get the current. Now we're dividing by a positive number. So this sign does not change direction. So the current is now less than or equal to 5 volts divided by 2 ohms. And that gives us volts over ohms is amps. So the current has to be less than or equal to 2.5 amps. Our question is, how did I know volts over ohms is amps? Well, in the textbook, there's a table that shows this relationship here.